Welcome to my short series on Git. This will take you from the very first step with Git up to being functionally proficient in it for most of the common use cases. These set of videos could also serve as a refresher for anybody who may have used Git in the past but just wants to catch themselves back up to speed. Everything you see in these videos will be valid on Linux, Mac, and Windows through something called Git Bash, which we'll talk about later. Let's just get right into it. So to start, what is Git? Git is a distributed version control system. And that word distributed is very important because Git being a distributed version control system is what sets it apart from the version control systems that it actually replaced, which were centralized systems such as SVN and CVS. The place where all code is stored is called a repository, and in the context of the Git distributed system, every computer that has downloaded the repository has a full copy of it. This also means that you can do work without being connected to a centralized server. This is another major difference between something like SVN and CVS. So the next question, of course, is why do we even need Git or really any version control software at all? And the simple answer is because tracking changes to files is very difficult, and it's difficult as a solo programmer, but it's even harder when you're working in a team. To help illustrate this point, let's look at a software workflow where you're not using a version control system. So imagine you're making a web application, and let's say that web application contains 100 different files. So you've made that and you've deployed it to the cloud and it works and everything's great. So now you go back to make some changes locally to a bunch of files. Say you change 12 or 15 files. How do you know which ones you've changed? Unless you have a very keen memory, you probably don't know which ones have changed. So how do you deploy your new changes to the cloud? So what you end up doing is you probably just take all 100 files and you just re-upload them to the cloud and just let them overwrite all of them. Now this may seem like an okay solution at first glance, but let's throw a second developer into the mix. So you've asked your friend to help you with your 100 file web application, so you've sent him a copy of all of the source code. Now let's say you've changed 5 of the files and your friend has changed 8 of the files, but 2 of the files he changed were also 2 of the files that you changed. The question now is, how do you and your friend reconcile the changes you both made and get them to the cloud server in a merged format? And the answer is it's going to be very difficult. What's ultimately going to end up happening is somebody's work is going to end up getting discarded. And obviously Git has way more features than just that, and it eases a lot of the burden for a lot of other things, but this is the main reason why. So since we're going to start working with Git a little bit, let's turn our attention to the installation of it. Installation is pretty straightforward regardless of the platform you're on. If you're on Linux, you can acquire it from your package manager of choice according to your Linux distribution. If you're on Mac OS, you can use brew to install it. If you're on Windows, you can go to git-scm.org and click on the download button. I'll put a link in the description for that, and then go through the installation process. Now, very important for Windows users, as you're going through the installation process for Git, when it comes to the point where it asks you if you want to use Git Bash, you want to say yes. Git Bash will give you the same Git usage experience as Linux and Mac OS users have, which is important since these videos won't be covering any graphical tools. Everything will be done at the command line. For Linux and Mac users, just go to your terminal and type git and just make sure something happens. For Windows users, you can open git bash and then type git and make sure you see the same thing. If you see something that looks similar to this, then you're ready to go. Since Git is also a means of distributing software, even if you have no intention on using it as a version control system, it makes sense to talk about the role of GitLab, GitHub, and Bitbucket since you inevitably come across those sites. We talked a little bit earlier about repositories as a place to store source code. We also talked about the distributed nature of Git in that every place that has that repository is a full copy of the repository. So the role of GitLab, GitHub, and Bitbucket is a place to have yet another copy of that repository, particularly one that's accessible to any system. Oftentimes people use GitLab, GitHub, or Bitbucket as the master copy of their repository. Now, of course, this is not strictly required. You don't have to use any of those services, but they do make it quite convenient. And a little bit later, we'll talk about how to create a repository, so don't worry about that. But let's just say you found a piece of software on GitHub and you want to use it yourself. You have Git and you'd like to pull a copy of it down to your system. So let's say you, purely in the context of a user, wanted to use the Engineer Man project Piston. There's a couple ways you could acquire this software. The first is just simply downloading a zip file of that software, but there's a better way, and that's to use git clone. To clone a repository, copy the URL, go to your terminal, type git clone, paste the URL, and hit enter. Congratulations, you've cloned your first repository, and the repository that you have on your system is the exact same one that's on GitHub. Now, this did more than just download the code from GitHub. It also added the Git specific files that makes this a Git repository. So now if I enter this directory and I run a git command, it knows that it's a Git repository. The second thing it did is it associated this repository with the version on GitHub, and this has an important impact. Basically, if the repository on GitHub ever changes, you can acquire those changes simply by running git pull. Of course, when I ran that, you can see it says already up to date, but that's because there's been no changes in the last 2 minutes. So what I've done is I've added some changes to the version on GitHub, so now when I do git pull, you can see it pulls in a bunch of changes. Remember earlier when we were talking about you and your friend working on the same website together? Well, if you're both using Git, then you could just download your friend's changes to your system without even knowing what he changed. The final thing we're going to talk about is how to create a repository, and you can create repositories from source code that already exists, or you can create a repository that's just blank with nothing in it. And the process is more or less the same. So I have a folder here called my existing project. So if I cd into that, I can simply run git init. And all git init really does is it adds the .git folder, and this tells Git that this is a Git repository and it should manage it as such. If you want to create a brand new blank Git repository, you can simply do git init and specify the folder name. So like my new project, and hit enter. So now in this folder, I have my existing project, which is now a Git repository. I have a blank project called my new project, which is a Git repository. And then I have the thing I downloaded from GitHub called Piston that is a Git repository as well. So at this point in the video, you should have a pretty good understanding on why Git is important and what the role of services like GitLab and GitHub are. You should also have Git installed, and you should know how to create a repo and how to clone a repo from GitHub or GitLab or Bitbucket. To learn more about interacting with Git, please be sure to click on the next video. Thanks a lot for watching.